Algebra 2. Today is lesson 12, and it's actually the last lesson before the first test. And it is a quick section. It's also review from geometry, and there's not much to it. So it's a pretty simple, should be kind of a short and sweet lesson. So lesson 12 is review from geometry. So in 12.A, they review angles and diagonals in polygons. Now there are two types of polygons. We spend most of our time with convex, but there are two types, concave and convex polygons. A concave polygon, first of all, is usually not regular, and one of the sides goes in towards the interior. Where convex, each one should be on the outside. Nothing should dip in. They should all be have an outside vertex. So a concave, that vertex is on the inside of the shape. Convex, all of the vertex, which is your points, should be on the outside. Okay, so two types. Again, we spend most of our time on convex polygons. So there's a couple properties for convex polygons. We're going to talk about both and I'm going to zoom in. We're going to talk about the sum of interior angles and exterior angles. And then we'll do an example. So sum, remember, would be if we added them all up, and for both interior and exterior, there are different rules. So the sum of interior, there's a formula. It's n minus 2 times 180 degrees. And n is the number of sides. Okay, so here's your formula. So for interior, I would use this formula here. And that is because I use that formula because I can divide every convex polygon into triangles. So for example, that pentagon, even though it's 5-sided, has 3 triangles. And notice the difference between 5 and 3 is 2. So that's why it's the number of sides minus 2 times, I know the sum of angles in every triangle is 180. So that's why I'm multiplying by 180. Now exterior, so if I had the same polygon and I'm looking at the sum of exterior, that would be if each of these was extended, and I'm looking at the exterior angles. Again, this should be review. So if I'm looking at the exterior, well, the exterior of any polygon is a full circle. So the sum of every exterior should just be 360 degrees. There's no formula for that. It's just the sum of exterior angles is 360, no matter how many sides it has. So an example. So I'm going to put an arrow. An example of this, find the sum of interior and exterior angles for a 7-sided convex polygon. Okay. So we're going to use the data from up above. So right away when I look at this, I know that the exterior equals 360 degrees because that is true of every polygon. And I know the interior angles, the sum of interior angles would be the number of sides, so 7 minus 2 times 180. Now remember, this is sum of angles, so that's why I have the degree symbol. So 7 minus 2 is 5. 5 times 180, I got 900 degrees. So those are my two answers, 360 and 900. Pretty simple. Okay, so I mean, if you'd like, we can do another one, but it's really that simple. So the next concept in this section is that every polygon can have several diagonals drawn. So I'm going to go over diagonals in a polygon. Okay, so diagonals are lines drawn from one vertex to another. And I'm sorry if you can't see all of that. And to find the number of diagonals drawn, it's a new formula. So, for example, what I mean by vertex to vertex. So this is not number of triangles. Okay, it's very different. From this top vertex, I can draw a diagonal to here and to here. Now I can't really draw it to these other 2 points because that would be the sides. So from this vertex, I can draw a diagonal from here to here. Those are 2 new ones. From this vertex, I can draw one to here, but that one's already drawn, so the only new one would be to here. When I get to here, the diagonal's already drawn. We're not going to repeat, and when I get to here, they're already drawn. So there are 1, 2, 3, 4, there are 5 diagonals in this 5-sided polygon. The formula for number of diagonals is n times n minus 3 divided by 2. So very similar to the above formula. Well, I guess it's not similar at all, except for the fact that remember that n is number of sides. Okay, so I'm going to do one example of that. Again, this isn't incredibly complex. So, how many diagonals are in a 7, I'm going to do 7 again, sided convex polygon? So if I have 7 sides, that would be 7 n right times 7 minus 3 divided by 2. That would give me 7 times 4 because we simplified parentheses first. So 28 divided by 2 would give me 14 diagonals. And that is the answer there. All right, next, kind of go over it quickly. Section 12, it has another part, 12.b, which covers proofs of a chord. It's a chord proof in a circle, and we won't do proofs in Trig. So we're going to skip that whole section, which is why we end up skipping problems in our homework, is because there's several things we skip in Trig. So we won't do proofs in Trig. So any section or any lesson that's on proofs, we skip. So that concludes lesson 12. I told you it would be short. For homework 12, you're going to skip number 9, 22 through 24, and 27. I believe those are all of them. If I look at the homework. Oh, and you can go ahead and skip 30. Okay? And that concludes your lesson. Hey.